This video is sponsored by World of Warships. You're watching Over the Edge from Event Horizon with John Michael Godier. John, what are you doing?
I'm playing my favorite game. I haven't even loaded it and my boat's already sinking.
There are sponsors, aren't they, John?
I'm happy to say they are, because this is a game that I really love and enjoy. If you're into naval architecture history, which is my other great love besides science, or just a great game, this is perfect, and it's free to download and play. World of Warships is a free-to-play game for PC and Mac. Command some of history's most iconic ships and unlock new ships as you prepare to dominate the oceans. With over 300 detailed warships, customizations, and upgrades, frequent events, and weather, there's enough to satisfy players of all levels. My favorite ship to play is the USS Atlanta, but there are also destroyers, other cruisers, battleships, and carriers, each of them with their own mechanics and gameplay. Use the link in the description below with the code READYFORBATTLE2020 to get started with a free package of 700 doubloons, 1,000,000 credits, 7 days premium account, and the premium ship USS Charleston with stars and stripes camouflage, and the premium Japanese ship, Anna, pronounce that.
Ishizuchi, John.
Thank you.
You told me it was a tactical simulation, John.
What? It is. I'm being totally tactical. Wait. The boat's leaking again. Anna, we need towels.
Oh dear. Why is the opossum in the bathtub?
Throw him a flotation device. We need a pump or something.
In today's episode, John is joined by Dr. James Annis. Dr. Annis is a senior scientist at the Center for Particle Astrophysics at the Fermi National Accelerator Laboratory. His current research is measuring the parameters of the cosmology model using clusters of galaxies, the weak lensing they cause, and their effect on the cosmic microwave background. His research also includes measuring the local expansion rate of the universe using optical observations of gravitational wave sources. He joined the Sloan Digital Sky Survey in 1993 as a postdoc. He helped found the Dark Energy Survey in 2003.
Now, Tim, what's your view on METI, out of curiosity? And, should we really go out of our way to broadcast a really loud signal, or should we just keep quiet?
I think we're saved by light travel time. I think we're doing it anyway, but light travel time is just light doesn't travel very fast on stellar distances. So it's a bad idea, I think, to be blasting radio messages at a globular cluster. I think we did that once.
The Arecibo signal.
On the other hand, it's going to take 10,000 years to get there. We probably will have other issues, and maybe in 10,000 years we'll be much better prepared if someone actually hears it and comes. I think it's more intellectual exercise. I think the way to think of METI is, yes, the human race civilization that we live here on Earth has to that. We have to figure out a way to all the people on the Earth that respects the governments that we have, that somehow they all work together and just don't let random rogue nations or bad companies do this. There's some thought process that leads to an informed METI or a decision not to do METI. I don't think we're in any immediate danger. There's not that many stars within 50 light years, a couple hundred.
I think what scares me more, actually, because if you're 50 light years out, our signals are pretty weak. You would need a pretty big radio telescope to detect us. But there's another problem. Earth has looked somewhat strange with its oxygen and methane levels for millions upon millions of years. So it's like, if anyone is studying exoplanets and they're looking at this one and they're saying, what could possibly be creating all that oxygen, then they would know that, or they could infer anyway, reasonably infer that Earth is a biosphere, and maybe a technological civilization is going to appear on it someday.
Yeah. And so now yeah, exactly. I mean, so what you just described was physics and astronomy. I mean, that absolutely, there's nothing we can do about it. Whether that's a problem or not depends on what your theory of arbitrarily advanced civilizations are. We have lots of science fiction novels to guide how to think about it, but we just don't know.
The nice thing being that given that the Milky Way looks entirely natural, there probably isn't anything here worth coming to get and crossing the vastness of space just to take our water or something like that. They probably have it locally or can get it much closer than coming here.
My vision for that is that handfuls of creatures, like 1,000 or 100, will travel between a star to another, and then a couple of thousand years later, they'll have enough entities in the new solar system to want to maybe move on to the next one. That doesn't. I don't think until we invent faster than light travel or some other way to get around the vast distances, resource attraction is not going to be going on. Or coming here to serve humans was a classic science fiction story. So that kind of thing is just not plausible. The aliens not going to come here to eat people.
Well, they probably couldn't digest us anyway.
They could just synthesize us, right? I mean, actually much more plausible is the replicators on Star Trek.
Yeah, and the fact is that some people have talked about gold. Gold is not rare. It's only rare on this planet because of the conditions of this planet. You go out in space, it's not rare. As a matter of fact, the kilonova produced a whole bunch of it, as I recall.
It was enormous amount. Tens of thousands of Earth's masses.
Yeah. All gold.
It's such a big, right? All gold. All other elements too, but in gold. So if you can space travel and you need, 10 Earth masses of gold, one can arrange it.
Now, what about phosphorus? That one is the one that seems to be a little bit odd. That we really don't know where the solar system got all this phosphorus. And there's questions about special case supernovas creating it and things like that. Is that the one thing that might make it valuable to travel the galaxy to mine? Or do you think there's just, even that isn't an option?
We're at a particle physics laboratory where our ability to change one particle to another is valued. It is easy to imagine you build isotope factory. You build something that you throw protons at the next element down from phosphorus enough so that it grabs enough neutrons and protons to go above it in the elemental table in the number of protons and neutrons. But it's unstable and it decays to phosphorus. I mean, we could build machines to do that now. They wouldn't produce a gram, but if we were desperate, we could do that. And desperate sort of defines, let's go 30 light years to go mine another planet for phosphorus. That sounds very desperate.
Yes, and it would be a particle accelerator. It'd be much more convenient.
Right.
Expensive though it would be.
Yes. I mean, I love the future where space travel is cheap, but it's not. It just doesn't look like it is until we some kind of faster than light travel. It looks hideously expensive.
Do you anticipate that we could ever do faster than light travel? I personally would be skeptical that we would ever be able to do it. Do you think it maybe could happen?
I think maybe. I don't believe anything that we have theories for now allow it. But you must understand what special relativity and general relativity are. They're theories that work extremely well, but they're not meant and never were meant to be final theories. They're no better or worse than Newtonian physics. They're what's demanded by a theory of special relativity may or may not be demanded by the universe. Was Arthur C. Clarke said, when a senior scientist tells you something is possible, they're almost certainly right. But they tell you it's impossible, they're almost certainly wrong.
I think that was, yes, Arthur Clarke.
So, yeah, I mean, what does that drive? Dallas Berry drive? I don't buy it. I don't buy it for a second. But it doesn't mean I don't believe that over a long duration, 1,000 years, 10,000 years, we can't develop faster than light drive using some trick that we just don't know anything about yet.
Now, there are a few hypotheticals, though, Einstein-Rosen bridges and Alcubierre warp drives, but these all seem to involve some form of exotic matter, negative mass matter. Do you think that's in the cards?
I thought so. That's a time travel machine that you're describing, and yes, I think that works. I think that the actual mechanism for holding the wormhole open long enough for something to travel through it is arbitrarily advanced technology, completely arbitrarily advanced technology. We do know of an energy that has negative pressure, but I think it needs more than that to hold those wormholes open. I think it's matter. I think it's high density stuff, not dark energy. It's not. So now, relative scale, which do I think is more plausible? Faster than light drive, or the wormhole opening technologies that allow them time travel? Probably the faster than light drive, because it's touch and go. They're both arbitrarily advanced. So I'll fall back on this. People talk about what's the odds of us detecting extraterrestrial intelligence, and they usually talk about 10 years, or if they're really reaching out, it's 50 years. And the question is more like, over the next 10,000 years, you think we'll detect it. And over 10,000 years, then you allow scientific theories to make advances and find surprises that let us do things that we don't think are possible now. That's a view I believe in.
One could look at things historically. If you were to go back to, say, the year 1805 and suggest that wireless communication over very long distances would be someday possible, they might not have believed you. They might have said, no, you'll never be able to do that. It's always going to be, somebody on a horse carrying a letter to a ship that goes across the ocean. But now we have radio, and that happened only 100 years after that. So there seems to be more cases in history of us not anticipating new technologies rather than actually nailing it. And that might be the case with faster than light travel, is that we just simply have not thought of the mechanism yet.
And it may not be for 1,000 years.
Or 10,000 years.
But it doesn't mean it's not impossible. It's like the Persian Empire. We really would like to have had radio, and there wasn't a chance. They could put all the money they wanted into it, and they weren't going to discover radio. We too could have a crash Apollo-style thing to try to get a faster than light drive, and odds are that would money be better spent elsewhere.
That would be interesting, because if the galaxy is indeed sort of just now forming intelligent civilizations, you could have the same sort of thing on a galactic scale, an arms race. Somebody, you see some evidence that somebody has developed faster than light travel,
yeah.
And then you better figure out how to do it yourself, and you end up with a Cold War galaxy, essentially.
Or a federation.
Or a federation, yeah.
I mean, you don't have to, you can be optimistic. It doesn't have to be the worst case scenario. So my personal favorite place to look for this stuff is Large Magellanic Cloud. So I think it's underappreciated. It's the nearest galaxy over. It's about 70,000 kiloparsecs, so 200,000 light years. But it fits in our modern telescopes well. Our instrumentation works on it well. I mean, so it's not the best for looking for faint radio sources. But if you're looking for, everything's all the same distance. Everything has the same brightness. You know what the brightness is. If you're looking for evidence of a growing civilization, LMC has a lot going for it.
That's interesting, because that's obviously just a companion galaxy, but why does it have a lot going for it?
It's fairly massive. So our galaxy, the Andromeda galaxy, are L-star galaxies, they're characteristic galaxies. It's sort of a normal giant galaxy. The LMC is a dwarf, maybe a factor of 100, maybe a factor of 10 less massive than ours, but it's only a factor of 10 or a factor of 100. So there's lots of mass there. There's lots of stars of all kinds. It's not just 100 star pool, which we know of those kind of things. And again, all the objects are at the same distance. So a lot of the problem in our galaxy until Gaia came along, so I'm now being dated, is that we don't know the distances of a lot of things. We have to guess the distances. It's very awkward, and getting the distance is half the problem. With Gaia, the parallaxes and the proper motions, we're going to understand the galaxy distances a lot better. But if everything's all at the same distance, it's easy to judge relative brightnesses. It's easy to look for anomalies because you know exactly what the astrophysics should be for an object at a given distance. And it fits into our instrumentation well. I'm mostly an optical astronomer, so my instrumentation are big cameras and large spectrographs. And in our galaxy, a lot of times we're using the state-of-the-art equipment. The stars are too bright. That's a feature, not a bug, but a lot of our equipment's not designed for bright objects.
Now, what's the history of the Large Magellanic Cloud? Is that a capture, or did that form along with the Milky Way?
Oh, that's not fully understood. What is understood was a very interesting, huge starburst in that galaxy 4 billion years ago, or 1,000 million years ago in the terminology. So about half the stars were formed at about the same time the sun was formed. I mean, that might be indicative of a capture event, but we know more about the star formation than we do about what caused the star formation event. There's a lot of stars that have exact same age as the sun. Yeah, we'll see.
Just from a standpoint of imagining mergers, past galactic mergers between the Milky Way and other galaxies in the past, and then also with these satellite galaxies, the idea of an entire galaxy, a separate one from somewhere else in space, being accessible to us as for study so that we can see, well, what are stars like in this galaxy, and what, things like that is fascinating because it sort of shows that the universe is really much the same all the way across the observable universe. There's not much variation in what happens. And that again would suggest that life is probably common, right?
To me, so I'm old enough to remember when people thought planets were rare. They were just wrong. As soon as there was enough instrumentation to detect planets, we detected planets everywhere. I suspect the same is true of life. My running bet is we'll find life on Mars, but it'll be Earth life blasted off from an asteroid strike on Earth and just carried by a rock to Mars.
Or vice versa. Earth life.
It's possible. Yeah.
Maybe everything started on Mars, and we're simply, when we set foot on that thing again, or for the first time rather, we will simply be going back to the home world.
Coming home. Exactly. So, but the ice planets are more interesting for independent life formation, right?
Yeah, sealed environments. Well, not really, because they tend to have fissures that spray material out, but for all intents and purposes, if you went and drilled into Europa and found an organism, microorganism, whatever, around the vents that bears no genetic resemblance whatsoever to Earth life, then there's your alien, Exactly. And that would also tell you that if it happened twice in a single solar system, abiogenesis, then it's probably happening everywhere.
Yep. And my evidence for intelligence lies is there's a mollusk that's nearly intelligent as a human. It just doesn't seem likely to me that intelligence is rare.
No, and one could also bring up the birds, tool-using birds, and all sorts of. You can teach a bird to talk, and apparently it can understand what it's saying to some degree. Yes,
I think so. We're on a different subject. I think scientists have a real problem with recognizing consciousness in other creatures because you just can't do it. If you're trying being so skeptical that you don't think a creature is intelligent or conscious, you can't even convince yourself the person you're talking to is conscious unless they tell you they're conscious. And for things like birds and dogs are different because they sort of co-evolved with us. But for things like birds and octopi, the way they're intelligent wasn't interesting to humans, and yet they're very intelligent in their own right.
Well, they can, in the case of the octopi, they can clearly problem solve.
Yeah.
But also the other mammals, if you look at groups of dolphins or orcas, they can actually work together in order to accomplish a goal. Say they have a seal trapped on a piece of ice. They have actually been seen to work together in order to wash the seal off so they can eat it. And we see that in a surprising amount of species on Earth. So that brings us to another scenario, is that okay, well, we were the first intelligent species on Earth, but will this planet spawn another civilization from one of these other animal groups? say we go extinct and we're not around to suppress that, I imagine we probably wouldn't want the octopuses to start launching rockets. But ultimately, if we go extinct, something else may arise here and do the same thing. And we have yet another technological civilization forming on a planet that produced multiple civilizations.
Sort of remarkably hard to rule out a technological civilization on Earth that happened a billion years ago. I would do it by saying there's no evidence of complex life forms. But the Earth resurfaces enough that it gets rid of all evidence of anything on the surface. And that's such a long time. I mean, you'd be looking for chemical layers in certain rocks formations. And I'm told that such layers that look sort of like the climate change event we're going through now have been seen in 30, 40, 50 million years ago in rocks. Yeah, I think we can rule it out, but it's surprisingly difficult when you actually get down to the details of saying, we're the first technological civilization on Earth.
Now, actually, Jason Wright wrote a definitive paper on that, right? Prior technological, indigenous technological civilization, something along those lines. And yeah, you can't rule it out, which makes you wonder, maybe we should be looking at the Oort cloud, Kuiper belt objects for city lights, which is another paper in and of itself, that, who knows what's out there. In which case, though, that's not aliens, that's Earth life. So if you did find
the
evidence...
moon looks pristine. The moon's surface is really old and it looks pristine. That's my best counter argument.
Yeah, and everything else. Yeah, they would have mined everything.
Or at least drove all over the surface a lot. But likely they would have paved it, bulldozed. Have you ever seen the mountain that we destroyed near Salt Lake City? There's a whole mountain peak that's now a hole in the ground.
That's actually happened several times. There is a mountain in South America that was very, very rich in silver ore. And it had been mined by natives before the arrival of the Spanish. But once the Spanish arrived, that mountain was so heavily mined that it's significantly shorter now than it was centuries ago. And we've actually altered it that much.
And I think that kind of thing, that kind of signature would show up on the moon after a billion years. It wouldn't look like an impact. You'd see something exotic and you would investigate it.
Which is interesting in and of itself, because a billion years from now, if anybody passes through in this explosion of intelligence, they will see the remains of our activities on the moon, presumably. Exactly. If we go and start mining the moon for helium-3 or one of those, the options that we have to do with the moon, then they're going to see that and they'll know. We will be someone else's artifact.
As opposed to Earth or Titan or probably Venus, where the evidence goes away pretty fast. The moon's a very slowly evolving thing.
Yeah, but the only thing that happens is the gardening, as I recall, as micrometeoroids strike it. That's about it.
So I actually don't know how long it would take. I don't know the expected lifespan of the tire prints of the Apollo astronauts. I mean, that'd be something we should know. I imagine something does know that.
Extremely long time. I haven't read about the tire prints, but the footprints are expected to last millions and millions of years. And eventually, so some alien could come along and say, what is this footprint? And why did they only have 2 feet instead of 6 or something like that?
So I was back to the prior indigenous civilization paper by Jason. He organized a Techno-Signatures conference in Houston 2 years ago. There was a lot of discussion of that paper there. And again, that's where this idea of this use of lunar orbiter and AI technologies and go look and see if we find any anomalous thing on the moon. We have actual things that we can use as truth tables. So all the probes that humans, the Russians, Americans, and Chinese and Indians have landed on the moon, we can use them as truth and look for anything else that looks even vaguely like them. It's a cool project. Someone needs to do it.
Yeah, well, there's a lot of, the search for technosignatures is just beginning. I know some people are like, well, can we detect CFCs in exoplanet atmospheres? And, and things like that. If you had to pick a technosignature, which one do you think is the most detectable? I guess I can't really guess that because you're asking about a field I'm not in. So the
That is a question. I'm an observer. That's a question about what instrument do I have, what resolution does it have, and what are the confounding features. Let me digress a second. Lithium is a product of stars and the early universe. It turns out we can measure lithium in stars. It's very difficult. It's super high resolution, and it's on the edge of a bigger line. So you're looking for a small squiggly line on a deep line. It's technically very challenging, yet it's doable. That is the kind of signature I imagine looking for CFCs or any other signature would be like. And I have no idea. I haven't researched it.
It's also probably one of the strangest examples of that, which has been mentioned by Jason Wright before on his blog, is Zhabilsky's star, which seems to have transuranic elements in it. And you're left wondering what could create that, because, Sagan and Shklovsky years and years ago said, well, if you ever see plutonium in a star, that might be a technosignature. And lo and behold, we apparently, or at least one group of Russian researchers apparently saw that. So it's like, what could create in nature transuranic elements? But then you got to wonder about things like getting bombarded by a neutron star or something that might create it. But that in itself is interesting, because then you get into questions about the island of stability and, these general mysterious things within chemistry that we haven't seen yet, in the creation of elements anyway. All right. We are out of time, Jim. It was a pleasure to talk to you today, and I hope you'll come back with us someday for more talk about the Fermi paradox.
Sure, or the cosmology, what my day job is.
Absolutely. Yeah, that too.
It'd be a pleasure. Thank you very much for inviting.
That was a bit of material that went over the edge. A bonus clip from a full episode of Event Horizon. New episodes every Thursday. So do be sure to hit subscribe. The full episode should be on your screen right about now.